Okay, good morning, guys. So we are back. This is going to be a second part of the lesson 8.2 on a hypothesis testing when standard deviation of the population is known. So last time we talked about a traditional method when you find a critical value, which is the z-score, that separation region, and then we find a test value, which is another z-score based on the information that we have from the sample. And then we basically compare the test value z-score and our critical value z-score. If our test value z-score is in the rejection region, which is that tail that we shade, then we reject the null hypothesis, otherwise we don't. So there is another method of testing hypothesis. They call them a p-value method. That's what we're going to be looking at today. Okay, so the p-value method is the probability value, basically, or they call it the percent value. So this is a definition. It says the p-value, probability value is the probability of getting a sample statistics, such as mean, that's what we're looking at now, in the direction of the alternative hypothesis when the null hypothesis is true. So this is like, sounds terrible, but basically when we're dealing with the p-value, instead of comparing the z-scores, we're comparing the actual areas. Okay, so. And so again, this is the traditional method, critical value, test value. The p-value, as I just said, we are comparing the actual areas, which is your alpha. That's your basically critical value area. That's your rejection region. And the p-value, which is the area based on that test value z-score that we find. And this is our steps. We're going to do them actually on the example. So let's do the example. Researcher wishes to test the claim that the average cost of tuition and fees at four-year public college is greater than $5,700. She selects a random sample of 36 four-year-old public colleges and finds the mean to be 5,950. The population standard deviation is 659. Is there evidence to support the claim at alpha, this is actually supposed to say alpha equal 0.05, and use the p-value method. So we start exactly the same way. So first step we do is we set up our hypothesis. So the first hypothesis, remember your null hypothesis, there is no change, meaning the mu equals to $5,700 because your mean tuition is $5,700. And alternative is hypothesis, H sub 1 or H sub A, as we talked about it previously, is mu greater than $5,700. And because this is what the researcher wishes to test, that would be the claim. That's the first step. The second step would be to find our critical value. But because we're using the p-value method, we don't need to find a critical value. So here, the second step will be computing the test value. So this is our formula. Plug in all our information. The mean for the sample minus the mean for the population, divide by standard deviation of the population over square root of the sample size. We get 2.28. And for the traditional method, we would stop because we would compare that z-score with our critical value. But because we don't have the critical value, so we're going to find the area that corresponds to that z-score. So we are looking at our table, and this is the z-score. Right, so we're going to find the area that corresponds to that z-score, and the area is 0.9887. as we remember, which actually I should have done from the beginning there, which I didn't, is to draw our pretty picture that we should do as soon as we set up the hypothesis. So this was a right tail. So this is the tail. So this is my rejection area. And that rejection area is my alpha. So alpha, let's suppose to say alpha, 0.05, meaning this area right here is 0.0500. Okay, so now we found the area correspond to that z-score, but as we know, the table always gives us the area from the left up to that point. So meaning this is 0.9887. So we're going to subtract it from 1 and to find the area of the tail. So we subtract it from 1 to find the area of the tail. Okay, and we get, what was it, 0.0013. And 0.0013 is less than this. So it's going to be somewhere in here, right? This area going to be. So it is going to be in the rejection region. 113, so this is actually you can subtract. So, and so again, this is our pretty picture. So our rejection area was 0.05. The area that we got from our test value is 0.0113, okay? And it's right here. So it is in the rejection region. So if it's in the rejection region, that means we reject the null hypothesis. So if we reject the null hypothesis, means we support the claim. So we would say there's enough evidence to support the claim that tuition greater than $5,700. Okay? Okay. Now, if you could see, if our alpha was 0.01, meaning at 1%, we would not reject that hypothesis. Okay? So another example in your notes. Researcher claims that the average wind speed in certain cities is 8 miles per hour. Sample of 32 days has an average wind speed of 8.2 miles per hour. Standard deviation of the population 0.6 miles per hour. At alpha 0.05, is there enough evidence to reject the claim? Okay, again, first step is state the hypothesis and identify the claim. So our null hypothesis, no change, meaning mu equals to 8 miles per hour. And alternative would be mu does not equal to 8 miles per hour. The question is, which one is the claim? As you can see, researcher claims that the average speed is 8 miles per hour. That means in this case, our claim is the mean. The claim is the null hypothesis. Okay, so now we're computing the test value. And we got 1.89. So we find the area, which is our p-value. So the z-score is 1.89, the area is 0.9706. Again, we have to subtract it from 1. We get this. And this is a two-tailed test. As we remember, our alternative was mu does not equal 8 miles per hour. Okay? So it's a two-tailed test. So the area is 0.0294. And because this is one tail, so to get the actual p-value, we have to multiply by 2, because again, let me draw a picture. And not equal. Remember, not equal makes it a two-tailed test. So when we found the z-score was like this 1, 1.80, well, not here, but the z-square was 1.89, our test value. We subtracted from 1, gives you 0.0294. That is a 1/tails area, 0.0294. We have to multiply it by 2 to get the p-value. So now this is the p-value. So now this is what we're comparing to our alpha. So this one is bigger than alpha. Okay, so if it's bigger than alpha, that means we do not reject the null. Okay, because as you can see, it comes out of with the tail, it's right here. So if it's greater than R, so we don't reject the null, and as we remember, the null was our claim. So because if it's a null hypothesis, we can't confirm the null hypothesis. We can only reject it or not reject it. So that means our summary will say there is not enough evidence to reject the claim that the average wind speed is 8 miles per hour. So when your claim is the null hypothesis, it said, you only can say that you can reject it or not reject it, okay? So again, when the claim is the alternative, you support it or you don't support it. When the claim is the null, you can only reject it or not reject it. Now this is the guidelines for the p-value. So if the p-value is less than 0.01, you reject the null hypothesis, you have a significance difference. If it's between 0.01 and 0.05, you still reject it, is the difference is significant. If it's less than 10%, 0.1, you actually have to consider the consequences of that one error before you reject the null. If it's greater than 1.1, you don't reject the null at all. This is your guidelines for the p-value. Okay, so speaking of significance, as a researcher, you have to be able to distinguish between statistical significance and practical significance. Just because something is significant statistically, a lot of times it has no practical use whatsoever. Okay? And that will be it for today. So this was the second part of lesson 8-2.